Now we're going to talk about a different type of sequence. Previously, the one that we used, we had to know the number before, and then we could figure out the next number. And that's really good for doing programming and looping commands. So here what we're going to do is have a type of formula or sequence called explicit. So an explicit sequence is a sequence that has terms that can be found without any knowledge of the previous terms. In an explicit formula, the nth term is described in terms of n. For this, each term is assigned a number. Write an explicit formula for the area of a square with side length n. So before we start writing that formula, what this is saying is basically that, you know what? I don't know what the previous number is, but I need to know what the 53rd term is in the sequence. That's what this type of formula allows us to do. So we don't have to know the whole sequence, and we can find a number that's way down the way without having to know the number ahead of it. So let's go back to this example from the previous page. And when we talked about a square, remember it was one side times the other side is equal to your area. So 2 times 2 equals 4 because on a square, all of your sides are equal. 3 times 3 equals 9. 4 times 4 equals 16. 5 times 5 is 25, and 6 times 6 is 36. So we want to write a generic formula for finding the nth one. Well, here's the thing. Here's term 1. This is term 2. This is term 3. Term 4. Term 5. Now we were talking about finding a square with n length and n width. So my sides would be n. So I can do that by saying a to the n is equal to n times n because that's the procedure that we did over here. Another way to write n times n is to write n squared. Both of them are correct. It's just that n squared is a little bit easier to read and it's a little bit more compact than n times n. Okay, let's go back to Mary Ann and her bank account. So she started with $75. And what we're going to do is find a formula for the amount of money in Mary Ann's bank account. So her total amount, or what she would have, starts out at 75. So no matter where we are on our terms, we have to add that 75 to it. So we're going to start with 75. And then what we're going to do is each of these terms, this is term 1, this is term 2, this is term 3, right? So each of those weeks, I'm going to take that and multiply it by 10. Now, why would I do that? The reason why I'm going to do that is because when I am at my second week, I've done 2 times 10 or 20 more than 75. When I'm at my third week, 3 times 10, I'm at 30 more than I was at 75. So this is an equation that will work for us. Sometimes what you have to do is just play around a little bit and see what you can get. And it's okay to make changes and adjust if you find that it just doesn't work. Okay, so before we run you down another rabbit hole, I wanted to give you a little trick on how to get these explicit formulas really easily. We haven't talked about this algorithm before, and an algorithm is just another name for a rule. So if I want to write an explicit formula, typically what I will do is a to the n equals, and then I will start with the very first term in my sequence, and then I will add to that the difference between my numbers times n minus 1, meaning that when I go a difference of 3 here for the first time, I'm only adding 3 on my second term. So this gives me the number 1. So let's use this example 7 as a way to kind of help explain this. If I go from 3 to 6, that's plus 3. 6 to 9, that's plus 3. 9 to 12, that's plus 3. So the difference between each of these is 3. I'm adding 3 each time. My initial term, or my first term, also happens to be 3. So just be careful about that one. It also happens to be 3. This one is related to that. This one is related to that. And then the n minus 1 essentially has me on my second term just adding it once instead of adding it twice. So it's an adjustment for us. So if I were to write this out using this formula, I would have a to the n equals 3 plus 3n minus 1. So let's test this out. 12 is my 1, 2, 3, fourth term. So I'm going to check out with something I know. So if I have a to the fourth, that's going to equal 3 plus 3 times 4 minus 1. So that's going to be 3 plus 3 times 3. So 3 plus 9, which is 12. So that checks out, right? That formula works for us. And then now what it wants us to do is find it for the 7th term. So did I need to do this? No, not really. But if I'm unsure, it's always good to check on one. So I'm going to do a to the 7. That's going to equal 3 plus 3 times 7 minus 1. So 7 minus 1 is 6. 6 times 3 is 18. So that's 3 plus 18. So that's going to give me the answer of 21. So A as my 7th term is going to be 21. All right, now that I've gone through it, let's see if we can more easily come up with our equation. So from 1 to 4, that's plus 3. 4 to 7, that's plus 3. 7 to 10, that's plus 3. So I know the distance or difference between these is 3. And then I'm going to look at what my first term is, which is this right here. My A1 is equal to 1, my first term. So I should be able to come up with an equation, which is a to the n equals A1. We're not going to put A1 in here. We're going to substitute it for this one specifically. 1 plus 3 to the n minus 1. Right? And again, here is my kind of my framework of blueprint of what I'm using. Let's check it with 10. So 1, 2, 3, 4. That's the fourth term. I'm not going to write as much on this one. A to the fourth equals 1 plus 3. 4 minus 1 is 3. So that's going to be 9 plus 1. That gives me 10. So that checks out. So now I'm going to look at the 12th term. So A to the 12 is going to equal 1 plus 3 times 12 minus 12 minus 1, excuse me. And that's equal to 1 plus 3 times 11, which is 33. So that gives me a value of 34. So a to the 12 is equal to 34. So I don't need to know 11 and A10 and A9 and A8 and A7 in order to be able to get this number. So this is a nice quick shortcut way of accessing all of these pieces. All right, last one. From 3 to 5, that's plus 2, 5 to 7, plus 2, 7 to 9, plus 2. At this point, I'm fairly confident, and so I'm not going to do a check on this. So I'm going to have my distance, or my difference, is going to be 2. My initial term is 3, and so I would write my equation a to the n equals 3 plus 2 times n minus 1. And then it wants me to find the 14th term. So that 14th term, a to the 14, is going to equal 3 plus 2 times 14 minus 1. So I've got 14 minus 1 is 13. 13 times 2 is 26. 3 plus 26 gives me 29. So a to the 14 is equal to 29.